4.6 Graphs of other trig functions. That's other trig functions like tan, cotan, secant, and cosecant. Let's dive in. Alright, I've created a little sketch. This is the unit circle again, or a circle I should say. Note that this point moves around freely. Notice this segment is the tangent segment to this segment inside the circle at this point. Watch how that segment behaves. Note that when this crosses pi over 2 angles, it flips sides. In fact, it goes off to infinity to the right, and then it comes from infinity from the left. Same case over here. It goes off to infinity to the left, and then it goes off to infinity to the right. That means that's asymptotic behavior. Notice the distance gets longer, and it goes up and up till it crosses, and then it goes down, and back up again. With that, this understanding and table, we should be able to start our graph. All right, I went ahead and set up the table. We have x and tan. Now with sine and cosine, we went from 0 to 2 pi. But with tan, we're going to need to do a few things a little bit differently, because tan doesn't quite behave quite like sine. Remember that tan is defined on the unit circle as y divided by x. So the quadrant angles, as you saw from before, cause a little problem at pi over 2 and 3 pi over 2. That's an asymptote at each of those values. We also need some more values then if we're going to not have pi over 2. One of the key points we're going to use is the pi's over 4, because this is when the y is equal to the x. So let's go ahead and clean this up, and let's go ahead and take the pi over 4 coordinates, which is square root of 2 over 2, square root of 2 over 2. When y is divided by x, then tan 45, or pi over 4, excuse me, we get 1. So we're going to count by pi's over 4, starting with 0. 0 pi over 4, pi over 2, then we have 3 pi over 4, and pi, spacing out. All right, once again, the reason I chose pi over 4 is because it gives us a critical value, an easy one to plot. Now at 0, the y is 0, but the x is 1. So it's 0 divided by 1, which is 0. At pi over 2, it's 0, 1. 1 divided by 0 is undefined, which means there's an asymptote there. Pi over 4, as you saw here, was 1. 3 pi over 4, remember that in the third quadrant, we have negative square root of 2, square root of 2 over, negative square root of 2 over 2, square root of 2 over 2, which means this is negative 1. And at pi, y is 0, but x is negative 1. So this is, y is 0. 0 divided by negative 1 is 0. That's our first table. That's really all we need to get, all we need to have to get started. Let's go ahead and start graphing with this table. All right, we have our table on the left. Went ahead and drew out a graph. Let's use this graph in this table and graph tan for the first time. Now, we got 0, 0. Plotting that point is pretty simple. We got 0, 0. I'm going to do an increment of pi over 4. The way I've got this set up, it's just not conducive to be able to write the increments. So I'm just going to write the increment over here and remember that I'm counting by pi's over 4, because that's what I have in the table. All right, so I've got 0, 0. Now I'd like to go to the next one, pi over 4, which is 1. And we have pi over 2, which goes off to infinity. That means I need an asymptote there. So I'm going to draw a dashed line at pi over 2. Then I'm going to continue. Notice we have 3 pi over 4 goes with negative 1. Then pi goes to 0. In fact, if you went back to the unit circle, note that the tan value starts repeating every pi. Let's see if we can get a sense of that. Notice tan is getting longer. Remember, we're focusing on this segment right here. So tan's getting longer. Oops. Tan's getting longer, and then it goes off to infinity. It gets shorter, goes to 0. Gets a little longer, goes off to infinity. Gets a little shorter, goes to 0. So notice it's repeating every pi. So with that, we can use our table, 0 and pi. So our table is going to repeat every time we do this. So I'm just going to repeat these values. So the next one over is going to go up to 1, because remember we're counting by pi's over 4. Then I've got an asymptote, and then I've got pi over 4, and so forth. So go ahead and finish this out. I'm going to pause the video. All right, remember the table's repeating every pi. I've got my points drawn out. Remember from the unit circle, we saw that tan was getting gradually bigger in that first one until it went off to infinity. All right, so we can take that notion that it's going off to infinity and the basic shape of a graph and continue that. That was terrible. Let's see if I can do this freehand. All right, so go ahead and draw the graph. And then repeat that for every single one. And that, my friends, is the tangent graph. Repeats every pi. So let's go ahead and identify some things that we know about it now that we've gone through it once. Remember that we've gone through this and we saw that the period was pi. Typically, we don't like to break up a period if possible when establishing a function. So we're actually going to call this function from negative pi over 2 to pi over 2, because then we wouldn't be breaking it up as we did when we started. All right, let's dive into some examples. All right, example number 1, it says that y is equal to tan x over 2. Just like from cosine and sine functions, we have to analyze the period because this angle is being affected. So instead of it being from 0 to 2 pi, we're going to use negative pi over 2, 2 pi over 2. Because if you remember from the original tan function, the value started repeating from negative pi over 2 to pi over 2. We don't like to break up the graph if at all possible. So let's come back here and let's set this equation up for x over 2 equal to pi over 2, negative pi over 2, and pi over 2. If we solve for x, note that x is now equal to negative pi and x is equal to pi. Let me go ahead and shrink this down. And use those values in my graphing. Now from this you can see that the period is now 2 pi because it's going to go from negative pi to pi. So it's got a period of 2 pi, but it's going to repeat every, and the asymptote's going to occur every odd number of pi because it's going to go from negative pi to pi, and we're going to add 2 pi to that to get 3 pi, and then 5 pi and so forth. So the asymptotes will occur at every odd pi, but our increment needs to be our pi over 2 because instead of being pi over 4, it's going to be pi over 2. So I'm going to increment this by pi over 4. We have negative pi to pi. Now that's where the asymptotes occur. If I do it in the increment within pi, then I'm going to run into a problem with graphing between them. It's not really that big a deal. I just prefer to not do that. So I'm going to do an increment of pi over 2. The original one was pi over 4. Now it's pi over 2. And it's halfway between, actually not halfway, it's a 3/4 way between this one and this one. All right, so I'm going to count by pi's over 2, but I'm not going to mark it up because it gets kind of messy in this video. But you might want to go ahead and mark it up to make sure that you're keeping it all organized. The asymptotes occur at every odd value of pi. You can think of it this way. Starting at pi, remember we're counting by pi's over 2, we have negative pi and pi. Note that there's a distance of 4 between these two, so I use that in creating the rest of the graph. So I have my other one over here, and my last one over here. Using the symmetry in the graph from the tangent function, I can go ahead and plot the other values. Remember, it crosses at 0, goes up 1. Same way over here. Down 1, 0, up 1. And then just graph as best you can a smooth tan function curve. Obviously, mine's not that neat, but that's okay because it gives you a basic sense of how the tan function is behaving. All right, that's example number 1. All right, for example number 2, we've got y equals negative 3 tan 2x. Now, just like the amplitude in sine and cosine, this number is going to change the tan function. But it's going up to infinity, so it's not going to make it go up any higher. Obviously, that's as high as it can go. Let me use the last example to describe what I'm talking about. Notice this is going to go up by 1. But instead of going by 1, it's going to be multiplied by 3. So then it's going to go up to 3. This one goes down by 1. So instead of going down by 1, it's going to be going down by 3 on this graph. But our period is different than the last one. Remember that the key values here are negative pi over 2 and pi over 2 when dealing with tan function, because that's when we don't split up the original tan graph. So I just set that argument, or the inside of tan, equal to these two values. And I divide by 2, and I get negative pi over 4 is equal to x, and I get x is equal to pi over 4. That means one period is going to exist from negative pi over 4 to pi over 4. That tells us that our period is the distance between those, which means it's pi over 2. It's going to repeat. We need 4 even divisions between those two, so I'm going to increment by pi over 8. Increment by pi over 8. Again, I'm not going to write this in the video because it gets really sloppy, but I'd recommend that you write that out, pi over 8, to confirm that you're understanding what's going on. So pi over 8. Notice that negative pi over 4 is 2 away from that, so that's going to be an asymptote there, and pi over 4 is an asymptote there. Let's go ahead and draw our asymptotes. And we've got our tan function. Notice the number in front is 3, and it's negative, which means it's going to flip over the x-axis, and instead of going down 1, this one's going to go up 3. And then instead of going up 1, this one's going to go down 3. Looks like I had the wrong tool. So up 3, 2, 3, and down 3. Crosses at 0. Just continuing the curve. This one's a little harder to do because it's so steep with the graph that I've made. And obviously, my graphing on this computer is not very accurate.
That's okay. That is y equals negative. That is y equals negative. That is y equals negative 3 tan and 2.